Welcome, weary traveler, to a quiet corner of the cosmos, a place where the universe whispers its secrets and the gentle hum of discovery lulls you into a peaceful slumber. Here, with The Sleepy Scientist, we don't rush through the wonders of the world. Instead, we invite them in, softly, allowing their grandeur to unfurl like a calming dream. Tonight, as you settle in, perhaps nestling deeper into your pillow or letting your eyes gently drift closed, we're going to embark on a journey that begins right beneath your feet, yet stretches far into the boundless expanse above. We're going to explore a question that has captivated minds for centuries, a question that, once understood, will deepen your connection to the vast, swirling dance of our solar system. Why does the Earth orbit the Sun? It's a question that brings forth images of planets gracefully gliding through the inky blackness, a celestial ballet performed in perfect, silent harmony. But what orchestrates this grand performance? What unseen forces keep our home planet on its steady path, circling that magnificent, glowing star? As you relax, let your thoughts drift. Much like our Earth drifts through space, imagine yourself suspended, weightless, observing our world from a distance. You see it, a vibrant blue marble, slowly spinning, bathed in the golden light of the sun. It's a breathtaking sight, isn't it? And it's this very sight that prompts our gentle inquiry tonight. We won't rush to the answers. Instead, we'll explore them with the same slow, deliberate pace that the Earth itself maintains on its cosmic journey. This isn't about memorizing facts, it's about understanding, about feeling the profound elegance of the universe, and letting that understanding guide you towards a truly restful state. So, breathe deeply, let your muscles soften, and prepare to unravel one of the most fundamental mysteries of our existence, not with effort, but with quiet curiosity. Our story, like many great cosmic tales, begins with something incredibly simple, yet profoundly powerful: gravity. Have you ever wondered what makes an apple fall from a tree, or what keeps your feet firmly planted on the ground? It's gravity, of course, that unseen pull that binds us to our planet. But gravity, my dear friend, is far more than just a force that pulls things down. It is the universe's most gentle, yet most insistent embrace, a silent conversation between every speck of matter that exists. Imagine gravity as a vast, invisible net woven throughout the cosmos, connecting everything, pulling everything subtly towards everything else. It doesn't scream or shout, it simply draws like an ancient, quiet longing. Think of it this way: every single thing that has mass, from the tiniest dust mote dancing in a sunbeam to the grandest star burning in a distant galaxy, has its own unique gravitational signature. It's like a quiet hum, a subtle whisper that reaches out and gently tugs at everything else. The bigger something is, the louder its whisper, the stronger its pull. The sun, that glorious fiery heart of our solar system, is an enormous collection of mass. Its gravitational whisper isn't just a whisper. It's a profound, resonant hum that extends across billions of miles, reaching out to every planet, every asteroid, every speck of cosmic dust within its vast dominion. It's this immense gravitational embrace from the sun that is the primary reason our Earth, and indeed all the other planets, remain in their graceful orbits. Let's imagine, for a moment, the Earth as a tiny boat, sailing on an endless, calm cosmic ocean. The sun, in this gentle analogy, is a colossal lighthouse in the distance, not just emitting light, but also radiating this invisible, pulling force. The boat, our Earth, feels this pull, drawing it ever so gently towards the lighthouse. Without this pull, our little boat would simply drift aimlessly into the vast unknown, lost in the cosmic currents. But the sun's gravity acts like an invisible tether, a silken cord that keeps our boat from straying too far. It's not a rigid, unyielding rope. Rather, it's like an elastic band, always gently tugging, always keeping our Earth in its designated dance space. This gravitational pull isn't just a simple tug, it's a constant, never-ending conversation. The Earth is constantly falling towards the sun, even as it moves forward. It's a little like throwing a ball into the air. It arcs, doesn't it? That arc is a result of the ball wanting to go straight. That's its natural tendency. We'll talk more about that later, but being constantly pulled down by Earth's gravity. Now, imagine if you could throw that ball so fast, so incredibly fast, that as it fell towards the Earth's surface curved away beneath it at the exact same rate. The ball would never actually hit the ground. It would just keep falling around the Earth, perpetually. This, in essence, is what's happening with our Earth and the Sun. The Earth is moving incredibly fast, and as the Sun's gravity tries to pull it in, the Earth's forward motion ensures it continuously misses the Sun, forever falling around it in an elegant, unending loop. This concept of constantly falling around might seem a little strange at first, but it's one of the most beautiful and fundamental ideas in celestial mechanics. It's a dance of never quite reaching, yet never quite escaping. And this dance, this cosmic waltz, is orchestrated by the invisible hand of gravity. It's a force that is always present, always working, always shaping the universe around us, from the smallest pebble to the grandest galaxy. As you lie here, feeling the gentle pull of the Earth beneath you, remember that this very same force, scaled to unimaginable proportions, is orchestrating the celestial ballet above. It's a reassuring thought, isn't it? To know that there's a quiet, dependable force keeping everything in its place, allowing us to rest soundly, knowing our planet is safely held within the sun's gentle embrace. This gravitational interaction isn't a one-way street, though. While the sun's immense mass exerts a powerful pull on the Earth also exerts a gravitational pull on the sun. It's a much, much weaker pull, of course, because the Earth is so much smaller, but it's there. It's a testament to the universal nature of gravity. Every single particle in the universe is subtly pulling on every other particle. It's a grand, intricate web of connections, each thread, no matter how small, contributing to the overall tapestry of existence. And this tapestry, this vast network of gravitational pulls, is what allows everything to move in such a harmonious, predictable way. So, as you drift deeper into relaxation, imagine the sun as a magnificent golden heart beating silently in the center of our solar system. From this heart, invisible lines of gravitational force extend outwards, reaching for all its planetary children, including our dear Earth. These lines aren't rigid or harsh. They are soft and yielding, allowing for movement, for a graceful, eternal orbit. The sun isn't just a source of light and warmth, it's a silent anchor, a cosmic guardian holding our world in its gentle, gravitational embrace. And this embrace, this fundamental force, is the very first secret of why our Earth dances so beautifully around the sun. Let this understanding settle over you, a comforting blanket woven from the threads of cosmic truth. Feel the quiet power of gravity, not as a heavy burden, but as a tender connection to something infinitely vast and wonderfully ordered. Now, let's explore this gentle embrace of gravity a little further. Shall we imagine you're holding a heavy stone and a small feather? If you drop them, the stone falls faster, doesn't it? This intuition, while true on Earth due to air resistance, isn't quite the full picture when it comes to gravity's pure pull. In a vacuum, without any air, a feather and a stone would fall at the exact same rate. However, what does matter immensely for gravity's strength is mass. The more mass an object has, the stronger its gravitational pull. This is a crucial concept, a quiet truth that underpins the entire celestial ballet we're discussing. Think of it like this: the sun is unimaginably massive. To give you a sense of scale, you could fit over 1 million Earths inside the sun. Yes, 1 million. That enormous amount of mass generates an incredibly powerful gravitational field, a sphere of influence that reaches out into the depths of space, tugging at everything within its grasp. It's the grand maestro of our solar system, and its sheer size gives it unparalleled authority in this cosmic orchestra. Without this immense mass, the sun wouldn't be able to hold on to anything. and our solar system as we know it simply wouldn't exist. The planets would have long ago drifted off into the cold, dark emptiness between the stars. But it's not just about mass, it's also about distance. The strength of gravity weakens dramatically with distance. This makes intuitive sense, doesn't it? Imagine trying to hear a whispered secret from across a vast, empty field. The further away you are, the harder it is to hear. Gravity acts in a similar way. The sun's powerful gravitational hum diminishes as you move further away from it. This is why planets closer to the sun, like Mercury and Venus, experience a much stronger gravitational pull than planets further out, like Jupiter or Saturn. It's this delicate interplay between the immense mass of the sun and the varying distances of its planetary companions that creates the unique gravitational environment for each world. Our Earth, nestled comfortably in its orbit, is at just the right distance from the sun for this gravitational pull to be strong enough to hold it, but not so strong as to pull it directly into the fiery star. It's a sweet spot, a perfect balance in the cosmic scales. If Earth were much closer, the sun's gravity would overwhelm its forward motion, and it would spiral inward. If it were much further, the sun's gentle tug would be too weak, and Earth would eventually wander off into the interstellar void. It's a testament to the elegant precision of the universe that such a perfect equilibrium exists, allowing life to flourish on our planet. Consider the other planets in our solar system, each a unique dancer in this grand gravitational performance. Mercury, tiny and swift, zips around the sun in just 88 Earth days, feeling the intense pull of its close proximity. Its orbit is tightly bound, a quick, energetic dance far out beyond the gas giants. Neptune takes nearly 165 Earth years to complete one orbit, moving at a much slower, more majestic pace. The sun's gravitational grip is far weaker there, but still strong enough to keep Neptune from escaping. Each planet, with its own unique mass and distance from the sun, has found its specific path, its designated rhythm in this cosmic ballet, all orchestrated by the twin forces of mass and distance dictating the strength of gravity. Imagine again that invisible net of gravity. Around the sun, this net is stretched taut and deep, forming a sort of gravitational well or funnel. The more massive an object, the deeper the well it creates in this cosmic fabric. The sun creates a vast, deep well, and our Earth rolls along the rim of that well, constantly drawn towards the center but always moving fast enough sideways to avoid falling in. It's like rolling a marble around the inside of a giant, invisible bowl. The marble is always trying to get to the bottom, the center of the sun's gravity, but its forward momentum keeps it circling the edges. This interaction isn't just theoretical. It's a constant, palpable force, even if we can't see it with our eyes. Every sunrise, every sunset, every changing season is a direct consequence of this gravitational dance. The warmth you feel on your skin from the sun's rays, the light that illuminates our days, all of it is part of this incredible, ongoing relationship. Without the sun's gravitational pull, our planet would simply careen through the darkness, a frozen, lifeless wanderer. It is this gentle yet powerful embrace that holds us, nourishes us, and keeps us on a path that allows for the remarkable phenomenon of life. As you continue to relax, let the image of this gravitational embrace settle in your mind. Picture the sun, so immense and powerful, extending its invisible arms out into space, gently drawing our Earth into a perpetual, comforting orbit. It's not a harsh pull, but a steady, unwavering connection. This connection ensures our days and nights, our seasons, and the very stability of our world. Feel the quiet power of this force, not as a weight upon you, but as a silent assurance that everything is precisely where it should be, held in the grand design of the cosmos. This understanding of gravity's role, particularly how mass and distance dictate its strength, is fundamental to comprehending the universe around us. It's the invisible architecture that builds galaxies, shapes nebulae, and holds solar systems together. It's the silent language that stars and planets speak to each other across unimaginable distances. And here, in our own cozy corner of the galaxy, it's the beautiful, enduring bond between our beloved Earth and its life-giving sun. As these thoughts gently swirl in your mind, allow yourself to feel more connected to the vastness, more at peace with the quiet certainty of cosmic laws. This knowledge isn't meant to excite, but to soothe, to deepen your appreciation for the unseen forces that govern our peaceful existence. Rest now, knowing our world is held in a powerful, yet gentle, cosmic cradle. As we continue our gentle cosmic journey, softly drifting through the vastness, we've begun to unravel the first great secret of why our Earth so gracefully orbits the Sun, the unseen embrace of gravity. We've learned that every object with mass possesses this quiet pull, and that the Sun, with its unimaginable bulk, is the grand orchestrator of our solar system's dance. But gravity, like a beautifully choreographed ballet, has subtle nuances, and its strength isn't uniform. It's dictated by two primary performers, the mass of the objects involved and the distance separating them. Understanding this delicate interplay is key to truly appreciating the silent majesty of our solar system. So, let's settle deeper into this understanding. Imagine, if you will, the Sun as an immense cosmic magnet, far grander and more powerful than any magnet you've ever seen, and our Earth, along with all the other planets, are like tiny iron filings drawn to this magnificent magnetic force. Now, think about how strong a magnet's pull is. It's strongest when the object is very close to it, isn't it? As you move the object further away, the pull weakens, becoming almost imperceptible at a great distance. Gravity behaves in much the same way. But instead of magnetism, it's the fundamental property of mass that creates the attraction. The more stuff an object is made of, the more mass it has, the stronger its gravitational influence. Consider the mighty Sun once more. It accounts for more than 99.8% of the total mass of our entire solar system. Picture that all the planets, asteroids, comets, and dust combined make up less than 0.2% of the total. This staggering imbalance in mass is precisely why the Sun is the dominant gravitational force. Its immense mass creates an incredibly powerful gravitational field, a cosmic well so deep that everything around it is drawn in. It's like a grand, silent sentinel, its sheer size dictating the movements of everything within its vast sphere of influence. This is why our Earth, despite its own considerable mass, is utterly beholden to the Sun's gravitational command. The Sun's gravitational voice is simply so much louder, so much more commanding, that it easily keeps our planet in its orbit. Now, let's turn our attention to the second crucial factor, distance. As we gently acknowledged earlier, the strength of gravity diminishes rapidly as the distance between two objects increases. This isn't a slow, gentle fading, it's a significant drop-off. In scientific terms, the gravitational force is inversely proportional to the square of the distance between the centers of the two objects. Don't let the technical words disturb your peaceful state. Simply imagine it like the light from a distant star. A star right next to us would appear brilliantly bright, but that same star, billions of light years away, is barely a twinkle. The further away you are, the weaker the perceived effect. Gravity works similarly. Its reach is vast, but its grip loosens dramatically with every passing mile. This principle of distance explains so much about the architecture of our solar system. Mercury, the smallest planet and closest to the Sun, experiences a tremendously strong gravitational pull. It whips around the Sun in a mere 88 Earth days, its orbit tightly bound and incredibly fast. The Sun's pull there is almost overwhelmingly powerful. Now, drift your thoughts outward, past our Earth, past Mars, past the mighty gas giants Jupiter and Saturn, all the way to Neptune, the farthest known major planet from the Sun. Neptune is nearly 30 times further from the Sun than Earth is. Because of this vast distance, the Sun's gravitational pull on Neptune is significantly weaker than it is on Mercury or even on Earth. Consequently, Neptune takes a stately 165 Earth years to complete just one orbit around the Sun, moving at a far more leisurely pace. It's still held firmly, mind you, but with a much lighter touch from the Sun's invisible hand. The beautiful thing about this relationship between mass and distance is that it creates a delicate cosmic balance, a perfect equilibrium for each planet. Our Earth, for instance, is situated at what we call the Goldilocks zone, not too hot, not too cold, and crucially, not too close nor too far for the Sun's gravity to maintain its orbit. The specific distance of Earth from the Sun ensures that the Sun's powerful gravitational pull is perfectly matched by another force, which we'll explore in our next gentle chapter. For now, simply appreciate that this precise distance is fundamental to our planet's stability. If Earth were just a little closer, the Sun's gravity would pull it into a tighter, faster orbit, perhaps even spiraling into the star itself over eons. If it were slightly further, the Sun's weakened grip might allow Earth to slowly drift away, eventually becoming a rogue planet, lost in the cold, dark interstellar expanse. It's a remarkable testament to the precision of the universe that our planet exists in this perfect gravitational sweet spot. This celestial dance, where planets of varying masses orbit at different distances, is nothing short of a cosmic ballet choreographed by these two fundamental principles. Imagine a grand ballroom, with the Sun as the massive, radiant conductor in the center. The planets are dancers, each with a different weight and a different assigned position on the dance floor. The heaviest dancers closer to the conductor feel a strong, immediate pull, twirling quickly in tight circles. The lighter dancers, or those further away, still feel the conductor's presence, but their movements are slower, more expansive, tracing wider, more leisurely arcs across the floor. Each dancer, each planet is perfectly attuned to the Sun's gravitational influence, moving in a perpetual, graceful rhythm. Consider the sheer elegance of this system. It's not chaotic, it's profoundly ordered. Every planet knows its place, its rhythm, its designated path, all thanks to the predictable, unwavering nature of gravity as influenced by mass and distance. This isn't just about the Sun pulling on the planets, it's also about the planets themselves having their own minuscule gravitational pulls on each other, and even on the Sun. Though these forces are far, far weaker than the Sun's dominant pull, they do create tiny, subtle perturbations in each other's orbits over vast stretches of time. It's like ripples in a pond, where a stone dropped far away still creates a small wave that eventually reaches the shore. These minor gravitational interactions contribute to the long-term stability and fascinating complexities of our solar system. But for now, for our peaceful understanding, let's keep our focus on the primary actors, the Sun's immense mass and the Earth's perfect distance. As you continue to feel yourself relaxing, perhaps your breath is growing shallower, your thoughts more ethereal. Imagine this vast cosmic ballet unfolding above you, millions upon millions of miles away, yet intrinsically connected to your very existence. Every time you gaze at the moon or ponder the distant twinkling of a star, you are witnessing the silent, ongoing work of gravity, a force that transcends our everyday experience but underpins everything we see and feel in the universe. It's a profound thought, isn't it? To know that the same gentle force that keeps your cup on the table is, on a grander scale, holding planets in their timeless orbits. Let this understanding wash over you like a soft, calming wave. The universe, in its boundless complexity, also holds a deep, reassuring simplicity. The fundamental forces that govern its grandest phenomena are often elegant in their design. Gravity, as dictated by the mass of objects and the distance between them, is one such elegant design. It ensures stability, order, and the beautiful rhythmic dance of celestial bodies. Our Earth is not wandering aimlessly. It is held gently yet firmly within the gravitational embrace of our Sun, a perfect balance of cosmic forces allowing life to bloom and flourish. As we conclude this chapter, Allow your mind to drift into a state of deep tranquility, knowing that you now hold a deeper appreciation for the unseen ties that bind our world to its star. Feel the comforting presence of gravity all around you, a silent guardian that keeps us grounded, both literally and figuratively, in the vast, wondrous tapestry of the cosmos. Our journey through the universe will continue, revealing more of its gentle secrets. But for now, let the quiet understanding of mass and distance settle into your peaceful slumber, ensuring a truly restful night. Welcome back, quiet observer of the cosmos, as we continue our gentle exploration into the elegant dance that keeps our Earth gracefully orbiting the Sun. We've already settled into the comforting embrace of gravity, understanding how the immense mass of the Sun, coupled with our Earth's specific distance, creates a powerful yet precise pull that holds our planet close. But there's another crucial player in this celestial ballet, a silent partner that ensures our Earth doesn't simply fall straight into the fiery heart of our star. This partner is called inertia, and it's a concept as simple as it is profound, one that allows our planet to perpetually miss the Sun in its endless journey. As you lie there, feeling the quiet rhythm of your breath, consider a simple act. If you were to gently push a book across a smooth, frictionless table, what would happen? It would continue to slide, wouldn't it? It wouldn't suddenly stop on its own. This natural tendency of an object to resist changes in its state of motion, whether it's at rest or already moving, is what we call inertia. It's the universe's quiet insistence on maintaining the status quo, a fundamental law that governs everything from a rolling ball to a swirling galaxy. In essence, an object in motion tends to stay in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. And here, in the cosmic theater, this unchanging nature of motion is just as vital as gravity itself. Now, let's bring this idea of inertia to our Earth. Our planet, as you might imagine, is not just sitting still in space. Oh no, it's hurtling along at an incredible speed. Think of it, Earth travels around the Sun at an average speed of about 67,000 miles per hour, around 107,000 kilometers per hour. That's incredibly fast, isn't it? It's this immense forward velocity, this relentless desire to keep moving in a straight line, that represents Earth's powerful inertia. If there were no other forces at play, if the Sun's gravity simply vanished, our Earth would not stop. It would continue to fly off into the depths of space, a solitary wanderer, forever moving in a straight line in the direction it was headed when the Sun's pull disappeared. So, here we have our two cosmic dancers, the Sun's powerful gravity, constantly trying to pull the Earth inwards, towards its fiery core, and the Earth's persistent inertia, constantly trying to carry it in a straight line, away from the Sun and into the vast unknown. It is the perfect, exquisite balance between these two forces that creates the elegant, perpetual orbit we witness. Imagine it like a continuous tug-of-war, but one where neither side ever truly wins, and in that eternal struggle, a beautiful equilibrium is achieved. Let's visualize this balance with a gentle analogy. Picture a child swinging a ball on a string around their head. The string represents the Sun's gravity, constantly pulling the ball inwards, preventing it from flying away. The ball's tendency to fly off in a straight line, if the string were cut, is its inertia. If the child doesn't swing the ball fast enough, the string pulls it in and it drops. If the child swings it too fast, the string might break and the ball flies away. But with just the right speed, the ball continues to orbit perfectly, never falling in, never flying off. Our Earth is like that ball, held in a delicate, continuous dance by the invisible string of the Sun's gravity and its own inherent forward momentum. This concept of continuous falling around might seem counterintuitive at first, but it's the key to understanding orbits. The Earth is, in a very real sense, constantly falling towards the Sun. But because it's also moving sideways at such an astonishing speed, by the time it has fallen a little bit towards the Sun itself and the entire solar system's common center of mass has moved a tiny fraction, and the Earth's forward motion has carried it to a new point where it's still missing the Sun. It's like an endless, graceful dive that never quite hits the ground because the ground is always curving away beneath it. This is why satellites stay in orbit around Earth, and why the Moon stays in orbit around Earth. They are constantly falling, but their tangential velocity, their sideways speed, keeps them moving around rather than into. Consider the sheer scale of this constant dance. Every second, as you comfortably rest, our Earth travels roughly 18.5 miles, or about 30 kilometers through space. This incredible velocity, this unwavering commitment to its straight path, is what allows it to resist the sun's powerful gravitational embrace. Without this forward motion, without this strong inertia, our planet would simply succumb to gravity's pull and plunge directly into the sun. It's a testament to the dynamic nature of our universe, where seemingly opposing forces work in perfect harmony to create stability and beauty. This dance of gravity and inertia isn't just unique to Earth and the Sun. It's the fundamental principle that governs all orbits throughout the cosmos. From tiny moons circling their planets to vast galaxies swirling around their central supermassive black holes. It's always this delicate balance. Every star, every planet, every cosmic dust particle is playing its part in this grand universal ballet, constantly moving, constantly falling, constantly resisting, creating an intricate, ever-changing yet endlessly stable masterpiece. As you let these thoughts gently settle into your mind, perhaps you can visualize it more clearly now. Imagine the Earth not as a static object, but as a dynamic entity, an intrepid voyager on an eternal quest. It's pulled by the powerful magnet of the sun, but it's also propelled by an unseen force that insists it moves forward. The two forces are locked in a perpetual stalemate, a cosmic arm wrestling match that results not in defeat, but in a never-ending, perfectly choreographed loop. It's a comforting thought, isn't it? To know that our world is not precariously balanced, but rather held in a state of exquisite dynamic equilibrium, a cosmic cradle rocked by the twin forces of attraction and motion. This understanding of inertia provides a profound sense of the universe's inherent order. It's not just about things falling, it's about things staying in motion unless something tells them otherwise. And in the vast emptiness of space, where there's no friction to slow things down, once something is set in motion, it tends to keep going forever. This means that the initial conditions of our solar system, how fast and in what direction the early Earth started moving, were just as important as the sun's gravity in determining its eventual orbit. It's a legacy of the universe's earliest moments, continuing to play out with every passing second. So, next time you look up at the night sky, or simply feel the ground beneath your feet, remember the silent partners at play. Remember the sun's immense drawing gravity reaching out with its invisible tendrils, and remember our Earth's tireless inertia, its relentless forward momentum, always striving to continue its journey in a straight line. It is the beautiful, harmonious interplay of these two forces, the pull and the push, the attraction and the persistence, that defines our planet's timeless path around its star. Let this quiet understanding deepen your sense of peace, knowing that our world is on a steady, unshakable course, guided by the fundamental laws of the cosmos. Drift deeper now, carried by the quiet certainty of this cosmic dance towards a truly restful sleep. Welcome back, peaceful traveler, to the quiet embrace of the sleepy scientist. We've gently explored the invisible threads of gravity, understanding how the sun's immense mass and our Earth's precise distance create a powerful pull. We've also acknowledged the Earth's unwavering inertia, its tireless desire to keep moving straight, ensuring it forever misses the sun. Now, as these two fundamental forces dance in a perpetual embrace, they sculpt something truly remarkable, the very shape of Earth's orbit. This isn't a perfect circle, as you might intuitively imagine, but something far more nuanced and, in its subtle imperfection, utterly beautiful. As you settle deeper into your restful state, allow your mind to envision this cosmic pathway. For centuries, many believed that planets moved in perfect circles. The circle, after all, was considered the most divine and harmonious shape, yet the universe, in its boundless wisdom, often favors elegance over perceived perfection. It was a brilliant astronomer named Johannes Kepler in the early 17th century who, through meticulous observation and profound insight, revealed that the planets, including our own Earth, do not follow perfectly circular paths. Instead, they trace out gentle, elongated ovals, a shape we call an ellipse. Imagine, if you will, drawing an oval. You might take a piece of string, tie its ends to two thumbtacks, and then, holding a pencil taut against the string, draw a continuous curve. The two thumbtacks represent the foci pronounced foci of the ellipse. For a planetary orbit, one of these foci is incredibly important. It's where the sun resides. This is a crucial distinction from a circle, where the center point is equidistant from every point on its circumference. In an ellipse, the sun is not precisely at the very center of Earth's orbital path. Rather, it's offset, sitting at one of these two focal points. This slight offset is what gives our orbit its distinctive oval shape and leads to some fascinating consequences for our journey through the year. Because the Earth's orbit is an ellipse, our planet is not always the same distance from the sun. Throughout our annual journey, there are times when we are slightly closer to our star and times when we are slightly further away. When Earth is closest to the sun, we call this point perihelion. This usually occurs around early January, when our planet is approximately 91.4 million miles, about 147 million kilometers from the sun. Think of it as the moment in the cosmic dance when Earth leans in just a little closer to its partner. Conversely, when Earth is farthest from the sun, we call this point aphelion. This happens around early July, with Earth stretching out to about 94.5 million miles, approximately 152 million kilometers away. It's a subtle difference, only about a 3% variation in distance, but significant enough to contribute to the intricate rhythm of our orbit. Now, you might gently wonder, if Earth is closest to the sun in January, why is it often so cold in the northern hemisphere during that time? And if we're furthest away in July, why is it so warm? This is a beautiful point that highlights how our intuition can sometimes mislead us. The shape of Earth's elliptical orbit is not the primary cause of our seasons. Instead, the seasons are overwhelmingly determined by the tilt of Earth's axis. Our planet isn't spinning perfectly upright in relation to its orbit around the sun. It's tilted by about 23.5 degrees. It's like our Earth is perpetually leaning to one side as it goes around the sun. Imagine holding a spinning top that's slightly tilted. As it moves around a central point, sometimes the top of the tilt points towards the light source, and sometimes it points away. When the northern hemisphere is tilted towards the sun, which happens in our summer, around June, that part of the Earth receives more direct sunlight, leading to longer days and warmer temperatures. When the northern hemisphere is tilted away from the sun, which occurs in our winter, around December, the sunlight hits it at a more oblique angle, spreading the same amount of energy over a larger area and resulting in shorter days and colder temperatures. The southern hemisphere experiences the opposite seasons because its tilt relative to the sun is reversed. So, while the elliptical path is a fascinating feature of our orbit, it's the tilt that truly paints the canvas of our seasons, not our slight variations in distance from the sun. This gentle elliptical path is a testament to the initial conditions of our solar system's formation. When the Earth was first coalescing from a swirling disk of gas and dust billions of years ago, it didn't just pop into existence at a perfect distance from the sun with a perfect circular motion. Instead, the gravitational interactions of countless tiny particles, and later, the gravitational influences of the nascent sun and other developing planets, imparted a specific amount of angular momentum to our Earth. This sideways push, combined with the sun's inward pull, resulted in this slightly oval pathway, a natural and efficient trajectory through the cosmic tapestry. Think of it as the most energy-efficient way for the Earth to perpetually fall around the sun without actually falling into it. A circular orbit requires a very specific, constant speed, which is difficult to maintain perfectly in a dynamic gravitational environment. An elliptical orbit, however, allows for subtle variations in speed and distance, creating a more robust and stable system over cosmic timescales. It's a natural consequence of the forces at play, a solution that the universe implicitly found to ensure the enduring dance of planets around their stars. As you drift deeper into relaxation, let yourself visualize this beautiful, slightly imperfect oval that is our Earth's home. Imagine tracing this path in the cosmic void, a gentle curve that takes a full year to complete. Feel the subtle shift as our planet moves from perihelion to aphelion, a quiet ebb and flow in our relationship with the great sun. It's a continuous, unbroken journey, a testament to the elegant mechanics of the heavens. This slight elongation, this graceful oval, is not a flaw. It is a fundamental characteristic of the orbital dance, adding another layer of wonder to our understanding of the universe. The understanding of this elliptical shape also gives us a deeper appreciation for the work of those early astronomers. Before telescopes and advanced mathematics, they observed the night sky with unwavering patience, tracking the delicate movements of the planets. It was through this dedicated meditative observation that Kepler was able to discern these subtle, non-circular paths, revolutionizing our understanding of the solar system and paving the way for Isaac Newton's later universal law of gravitation. It's a reminder that even the most profound scientific truths often begin with quiet, focused contemplation, much like the peaceful introspection we invite you into tonight. So, as you continue to relax, let the image of Earth's elliptical orbit be a soothing thought. Our planet is not rigidly bound to a perfect circle, but rather glides along a path that embraces gentle variation, a natural rhythm of closeness and distance. This subtle oval, shaped by the dance of gravity and inertia, ensures our steady journey around the sun, allowing the cycle of days, nights, and seasons to unfold with predictable grace. Our home is truly nestled in a cosmic cradle, following a timeless, elegant path. Rest deeply now, wrapped in the quiet certainty of our Earth's beautiful, elliptical journey through the stars. Welcome back, calm explorer of the cosmos, as we continue our tranquil journey through the silent ballet of our solar system. We've settled into the profound understanding of gravity's embrace and the persistent spirit of inertia, which together sculpt our Earth's gentle elliptical path around the sun. Now, as our planet glides along this graceful oval, there's another fascinating detail that adds to the intricate beauty of its motion. The speed of its orbit isn't constant. It subtly changes, quickening and slowing in a mesmerizing rhythm that reveals even deeper layers of cosmic harmony. As you drift further into your peaceful state, let your mind quietly ponder this subtle acceleration and deceleration. You might instinctively think that if Earth is always falling around the sun, it would maintain a uniform speed, but the elliptical shape of its orbit introduces a beautiful variation. Remember our talk about perihelion, when Earth is closest to the sun around early January, and aphelion, when it's farthest around early July. These points are not just about distance, they are intimately connected to our planet's velocity. Here's the gentle secret: when Earth is closer to the sun, at perihelion, it actually speeds up. It moves faster along its orbital path. And conversely, when it's farther away, at aphelion, it slows down. This might seem counterintuitive at first, but it makes perfect sense when you consider the dance between gravity and inertia. When Earth is closer to the sun's gravitational pull is stronger, like a powerful hand gently giving our planet an extra tug. This increased pull accelerates the Earth, causing it to cover more distance in less time. As the Earth then swings away and begins its journey toward aphelion, the sun's gravitational pull weakens slightly due to the increased distance. With less of that powerful pull, Earth's forward momentum, its inertia, causes it to continue moving, but at a slightly slower pace, allowing the sun's weaker gravity to still keep it in check without pulling it too sharply inward. This phenomenon is elegantly described by one of Johannes Kepler's profound insights, often referred to as Kepler's second law of planetary motion. Don't let the grand name disturb your serenity. Think of it simply as the law of equal areas. It states that a line connecting a planet to the sun sweeps out equal areas in equal amounts of time. Imagine a giant, invisible broomstick extending from the sun to the Earth. As the Earth orbits, this broomstick sweeps across the vast expanse of space. When Earth is near the sun and moving faster, that broomstick sweeps a wide, short arc, covering a large area quickly. When Earth is far from the sun and moving slower, the broomstick sweeps a narrower, longer arc, but it still covers the same amount of area as the wider, shorter arc in the same amount of time. It's a beautiful demonstration of nature's inherent mathematical precision, a cosmic clockwork that ensures a harmonious rhythm regardless of distance. This constant adjustment in speed is not just a scientific curiosity, it's a testament to the dynamic stability of our solar system. If Earth somehow maintained a perfectly constant speed throughout its elliptical orbit, the delicate balance between gravity and inertia would be disrupted. If it moved too slowly when close to the sun, it would spiral inward. If it moved too quickly when far away, it would escape the sun's gravitational grasp. The subtle speeding up and slowing down is the universe's elegant solution to maintaining a stable, enduring orbit. It's a self-correcting mechanism, ensuring that our planet remains perfectly balanced in its perpetual fall around the sun. Consider the implications of this varying speed on our perception of time and the unfolding of our year. While the change in Earth's speed is significant in cosmic terms, it's not something we consciously feel in our daily lives. Yet, it means that the duration of our seasons isn't perfectly identical. For example, because Earth moves faster when closer to the sun, the northern hemisphere's winter and the southern hemisphere's summer is slightly shorter than its summer and the southern hemisphere's winter. This is because Earth covers the winter portion of its orbit more quickly. It's a tiny difference, only a few days, but it's another subtle layer of intricacy woven into the fabric of our annual journey. This natural acceleration and deceleration, this ebb and flow of planetary speed, is a reminder that the cosmos is a living, breathing entity, constantly adjusting, constantly in motion. It's not a rigid machine, but a fluid, adaptable system where everything influences everything else in a delicate, interconnected web. The sun doesn't just pull, it influences speed. The Earth doesn't just move, it adjusts its pace in response to the sun's ever-changing gravitational grip. It's a dance of mutual influence, a continuous dialogue between the celestial bodies. As you allow your consciousness to deepen, imagine yourself floating alongside Earth, observing its majestic journey. You see it gently picking up speed as it approaches the warm embrace of perihelion, then gradually easing off as it ventures further out towards aphelion, only to begin its gentle acceleration once more. It's a graceful, never-ending cycle, a testament to the universe's enduring stability. There is no struggle, no effort, just the smooth, predictable unfolding of physical laws that ensure our world's continued existence. This understanding of Earth's varying orbital speed brings a new dimension to our appreciation of the solar system's mechanics. It demonstrates that not only are the paths of planets elliptical, but their very motion along those paths is a dynamic, rhythmic response to the sun's gravitational field. It's a beautifully intricate design, ensuring longevity and consistency for billions of years. Let the steady, rhythmic pulse of this cosmic dance lull you deeper into your rest. Feel the calm assurance that our planet, guided by these elegant physical laws, continues its ancient, unchanging journey. Our world is held in a state of harmonious balance, a perfect blend of force and motion, gracefully spinning and orbiting through the quiet vastness of space. Rest now, with the gentle rhythm of Earth's cosmic waltz guiding your dreams. Welcome back, peaceful voyager, as we continue our gentle drift through the cosmic wonders that shape our existence. We've quietly absorbed the essence of gravity's embrace, understood the unwavering spirit of inertia, and admired the subtle beauty of our Earth's elliptical path and its varying speed. Now, let us broaden our gaze beyond our own familiar world and consider the grand spectacle that is our solar system, a vast cosmic family of dancers, each with its own unique rhythm and role, all held in a magnificent, interconnected ballet around our radiant sun. As you settle deeper into your serene state, imagine standing at a cosmic vantage point, high above our solar system, looking down upon its intricate movements. You wouldn't just see Earth and its moon, you would behold a mesmerizing panorama of planets, dwarf planets, countless asteroids and distant comets, all swirling in a captivating, continuous performance. Each of these celestial bodies, in its own way, tells a story of the delicate balance between the sun's gravitational dominance and its own inherent momentum. Think of Mercury, the smallest and innermost planet, scorching hot and barren, zipping around the sun in a mere 88 Earth days. Its orbit is tightly bound, a quick, almost frantic dance around the central star. The sun's gravitational pull on Mercury is incredibly intense due to its close proximity, requiring Mercury to maintain an astonishingly high orbital speed to avoid being pulled directly into the sun's fiery embrace. It's like a dancer spinning incredibly fast, close to the center of the stage. Then, moving outward, you'd see Venus shrouded in thick swirling clouds, taking 225 Earth days for one solar circuit, and then our very own Earth, the vibrant blue marble we've been exploring, completing its journey in a familiar 365 days. Beyond us, Mars, the rusty red planet, with its thinner atmosphere and polar ice caps, follows a more leisurely pace, taking nearly 2 Earth years to complete its orbit. Each of these rocky inner planets, though differing in size and speed, exists in its own gravitational harmony with the Sun, a testament to the principles we've discussed. But the story of our solar system truly expands when we cross the vast asteroid belt, a swirling ring of rocky debris that acts as a boundary between the inner, rocky planets and the colossal giants of the outer solar system. Beyond this belt lie the gas giants Jupiter, the king of planets, so immense that all other planets in our solar system could fit inside it. Saturn, with its magnificent icy rings, a breathtaking jewel of the cosmos. Uranus, the sideways tilted ice giant, rolling along its orbital path. And finally, Neptune, the distant frigid blue world, slowly making its journey at the very edge of our known planetary family. Each of these outer planets, particularly Jupiter, holds a special significance in the grand scheme of the solar system's gravitational stability. Jupiter, with its enormous mass more than twice the mass of all the other planets combined, acts like a mini-sun in its own right, gravitationally speaking. While its primary orbit is dictated by the Sun, Jupiter's immense gravity exerts a significant pull on its neighboring planets and, fascinatingly, acts as a cosmic sweeper or guardian. Its strong gravitational field has cleared out much of the debris in its orbital path and in the asteroid belt, preventing countless potential collisions that might otherwise have plagued the inner planets, including our Earth. It's like a giant, benevolent older sibling, helping to keep the dance floor tidy and safe for the smaller dancers. The orbits of these outer planets are much wider and their speeds much slower, reflecting the weaker gravitational pull of the Sun at such immense distances. Neptune, for instance, takes nearly 165 Earth years to complete just one single orbit around the Sun. Imagine the patience of such a world, drifting slowly through the cold, dark reaches of space, held only by the incredibly gentle, yet persistent, tug of our distant Sun. Yet, despite their vast distances and differing characteristics, every single one of these planets, from Mercury to Neptune, is participating in the very same gravitational dance, obeying the same laws of motion and attraction. This grand diversity of orbits, the tight, fast circuits of the inner planets versus the vast, slow journeys of the outer giants, showcases the versatility and robustness of gravitational mechanics. It's a system where every component, from the smallest asteroid to the largest planet, finds its unique, stable path, all without a single visible string or tether. This enduring stability, maintained over billions of years, is what allowed life to emerge and thrive on our Earth. If our solar system were chaotic, with planets constantly colliding or veering off into space, such a sustained environment for life would be impossible. As you allow these images to form in your mind, let the sheer scale and harmony of our solar system wash over you. It's not just a collection of isolated worlds, it's an interconnected family, each member influencing the others, however subtly. The sun is the beating heart, the gravitational anchor that holds everyone together. But the planets themselves, particularly the giants like Jupiter, play crucial roles in maintaining the overall balance and order of this magnificent system. It's a symphony of forces, each note perfectly placed, each movement flawlessly executed, resulting in a performance that has endured for eons. This journey through our solar system, witnessing the diverse yet unified dance of its members, offers a profound sense of peace. It reminds us that even in vastness, there is order. Even in constant motion, there is stability. Our Earth is not alone. It is part of a grander family, a cosmic neighborhood where every member contributes to the overall harmony. Let the quiet rhythm of this knowledge lull you deeper into your rest, knowing that our planet is but one elegant dancer in an infinitely majestic, incredibly well-ordered cosmos. Our world is held not just by the sun, but is part of a larger, gravitationally bound family, a stable and beautiful testament to the universe's inherent design. Rest deeply now, wrapped in the quiet certainty of our solar system's grand, eternal dance. Welcome back, tranquil dreamer, as we continue our gentle journey through the cosmic ballet that shapes our world. We've explored the immense gravity of the sun, the tireless momentum of inertia, the subtle beauty of our Earth's elliptical path, and the varied speeds of our solar system's dancers. Now, let us turn our gaze to a familiar face in our night sky, a close companion that profoundly influences our very existence, our own moon. This silvery orb isn't just a distant light, it's a celestial partner, engaged in its own graceful orbit around Earth. And in doing so, it adds another layer of subtle, yet powerful, gravitational influence to our planetary system. As you settle deeper into your restful state, imagine our Earth, this vibrant blue marble, not as a solitary figure, but with its loyal companion, the moon, constantly circling it. The moon, much like the Earth orbits the sun, is held in Earth's gravitational embrace. It's a smaller, quieter dance within the grander performance of the solar system. Our moon is Earth's only natural satellite, a constant presence that has shaped our planet's history and continues to touch our daily lives in ways you might not consciously realize. Think of the moon's journey around Earth. It takes roughly 27.3 days to complete one orbit, a familiar cycle that has guided human calendars and folklore for millennia. This steady rhythmic movement is, once again, a testament to the balance between Earth's gravity and the moon's inertia. Just as the sun pulls on Earth, Earth pulls on the moon. And just as Earth has its own forward motion, so too does the moon, always striving to move in a straight line, but constantly being curved into an orbit by Earth's relentless gravitational tug. It's a beautiful miniature version of the Earth-Sun system, playing out right above our heads. But the moon is more than just a satellite. Its gravitational pull has a profound and palpable effect on our home planet. The most striking example of this influence is the phenomenon of ocean tides. Have you ever watched the ocean water rise and fall along a coastline? That rhythmic ebb and flow, twice a day in most places, is primarily caused by the moon's gravitational pull. The moon's gravity gently tugs at the Earth, and since water is fluid, it responds by bulging outwards on both the side of Earth facing the moon and the side directly opposite it. These bulges are the high tides, while the areas in between experience low tides. It's like the moon is subtly kneading our planet, drawing the waters of our vast oceans with an invisible, rhythmic hand. This tidal influence isn't just about the oceans. The moon's gravity also creates body tides in the solid Earth, though these are much less noticeable. The land beneath your feet actually rises and falls by several inches twice a day, pulled by the moon's distant hand. It's a testament to the immense power of gravity, even from afar, that it can subtly deform the very crust of our planet. Beyond the daily rhythm of the tides, the moon plays an even more crucial long-term role in maintaining the stability of our planet. It helps stabilize Earth's axial tilt. Remember how we discussed that the tilt of Earth's axis is responsible for our seasons without the moon. Earth's axial tilt would wobble far more dramatically over long periods of time. Imagine a spinning top. If you give it a gentle nudge, it might wobble a bit, but if you give it a consistent push, it could eventually topple over. The moon, through its gravitational pull, acts like a cosmic stabilizing weight, gently dampening Earth's wobbles and keeping our planet's tilt relatively constant. This stability is incredibly important for life on Earth. A constantly shifting axial tilt would lead to extreme and unpredictable climate changes, making it far more challenging for life to adapt and flourish. Imagine seasons that drastically change their intensity over thousands of years, or even times when the poles might directly face the sun. The moon, therefore, isn't just a beautiful ornament in our night sky. It's an essential partner, a quiet guardian that helps ensure the long-term climatic stability necessary for our planet's enduring habitability. It's a profound connection, a deep bond that has fostered the very conditions for life as we know it. So, when you look up at the moon, whether it's a sliver of silver or a full, luminous orb, know that you're not just seeing a distant rock. You're witnessing a continuous, ancient dance, a gravitational embrace that directly affects the oceans, the land, and the very climate of our world. The moon is a silent, diligent worker, endlessly orbiting, endlessly influencing, a vital part of the larger cosmic symphony. As you feel your mind becoming increasingly serene, let the image of our Earth and its faithful moon be a source of calm. Picture them together, a pair of dancers, orbiting each other while simultaneously orbiting the sun. It's a nested dance, a beautiful illustration of how gravitational forces operate on multiple scales, creating interconnected systems of immense complexity and profound stability. Our existence here, on this beautiful planet, is inextricably linked to the graceful presence and powerful influence of our lunar companion. This understanding of the moon's gravitational role adds another layer of appreciation for the intricate design of our solar system. It shows us that every celestial body, no matter its size, plays a part in the grand cosmic order. The moon's quiet, persistent pull on our oceans, its steadying hand on our planet's tilt. These are not random occurrences, but fundamental interactions that contribute to the delicate balance that makes Earth a home for life. Rest now, dear friend, with the comforting thought that our world is not only held in the sun's vast embrace, but also cradled by the gentle, unwavering presence of our loyal moon, ensuring a stable and harmonious journey through the stars. Allow this knowledge to lull you deeper into your peaceful slumber, wrapped in the serenity of our Earth's lunar guardian. Welcome back, peaceful mind, as we continue our gentle journey through the cosmic tapestry, unraveling the profound reasons behind our Earth's graceful dance around the sun. We've drifted through the embracing power of gravity, the persistent journey of inertia, the subtle beauty of our elliptical path, the changing speed of our orbit, and even the profound influence of our constant companion, the moon. Now, let us turn our thoughts to the very beginning, to the quiet, swirling chaos from which our sun, our Earth, and indeed our entire solar system were born. This is a story of cosmic beginnings, a tale where gravity, once again, plays the role of the grand architect, pulling disparate elements together to form the harmonious system we inhabit today. As you settle deeper into your serene relaxation, imagine looking back in time, not just thousands or millions of years, but billions of years. Picture an unimaginably vast, cold, and dark cloud floating in the emptiness of space. This wasn't an empty cloud, though. It was a cosmic nursery, composed primarily of hydrogen and helium gas, interspersed with tiny specks of dust, the stardust, if you will, remnants of long-dead stars from previous generations of the universe. This was the primordial material, the raw ingredients from which our sun and all its planets would eventually emerge. Now, in this vast, diffuse cloud, imagine tiny, imperceptible variations in density. Perhaps a slight puff of gas here, a minuscule clump of dust there. Even these tiniest irregularities, due to the universal law of gravity, began to exert a gentle, almost imperceptible pull on their immediate surroundings. It's like a quiet whisper in a vast hall, but over immense stretches of time, these whispers began to coalesce, to grow louder, drawing in more and more of the surrounding gas and dust. This process, driven solely by the relentless, quiet insistence of gravity, is the very first step in the formation of stars and planetary systems. As these initial clumps grew, their gravitational pull became stronger, attracting even more material. It was a snowball effect, accelerating over millions of years. This ever-increasing mass began to contract, slowly, inexorably, pulling itself tighter and tighter. As this enormous cloud contracted, two crucial things began to happen. First, the shrinking mass began to rotate. Think of an ice skater pulling in their arms as they spin. They spin faster, don't they? The same principle applies here. As the vast cloud collapsed inwards, the conservation of angular momentum caused it to spin faster and faster, gradually flattening into a vast rotating disk, much like a cosmic pancake. This spinning motion, this inherent angular momentum, would later become the source of the inertia that keeps planets from falling into the sun. Second, as the center of this collapsing obtuse, spinning disk became denser and denser, the pressure and friction generated by the accumulating matter caused its temperature to rise dramatically. Imagine all that gas and dust squeezing together, compressing more and more tightly. This immense pressure and heat at the core of the disk eventually ignited nuclear fusion, the process by which hydrogen atoms fuse to form helium, releasing an unimaginable burst of energy in the form of light and heat. And with that ignition, approximately 4.6 billion years ago, our magnificent sun was born, blazing forth in the heart of the nascent solar system, a true star shining for the first time. While the sun was forming at the very center, the remaining gas and dust in the surrounding flattened disk continued to swirl and interact. In this vast protoplanetary disk, as it's called, gravity continued its work on a smaller scale. Tiny particles of dust and rock, gently pulled by gravity and occasionally colliding, began to stick together. Over vast stretches of time, these minuscule clumps grew into larger and larger aggregates, like cosmic dust bunnies. These clumps, now called planetesimals, continued to collide and accrete, slowly sweeping up more and more material from the disk. This process of gradual accumulation, driven by localized gravitational pulls, eventually led to the formation of the planets we know today. The conditions within the disk varied with distance from the young sun. Closer to the fiery star, where temperatures were higher, lighter elements like hydrogen and helium were mostly blown away by the sun's strong early solar winds. This left behind heavier, rocky materials, which coalesced to form the smaller, dense inner planets like Mercury, Venus, Earth, and Mars. Further out, in the colder reaches of the disk, the lighter elements could remain, and enormous amounts of gas and ice accumulated around rocky cores, forming the colossal gas giants like Jupiter and Saturn, and the ice giants Uranus and Neptune. So, the very act of formation for our solar system was a grand testament to the power of gravity. It was gravity that initiated the collapse of the vast gas cloud, gravity that led to the birth of our sun, and gravity that continued to pull together the scattered remnants of the disk into the distinct planets. Each settled into its own unique orbital path. And crucially, the initial spinning motion of that collapsing cloud imparted the necessary angular momentum, the sideways push that ensures these newly formed planets would not simply fall into the sun, but would forever orbit it. This inherent spin became the inertia we discussed, setting the stage for the endless dance. As you conclude this journey to our cosmic origins, allow the vastness of time and the elegant simplicity of these processes to fill you with a profound sense of awe and peace. Our solar system is not a random collection of celestial bodies. It is a meticulously sculpted masterpiece, born from the quiet, persistent work of gravity and the fundamental laws of physics. Every planet, every asteroid, every cometary ice ball is a remnant of that grand formation, forever bound in a gravitational relationship initiated billions of years ago. Let this understanding deepen your sense of connection to the universe. We are, quite literally, made of stardust, formed from the same ancient materials that coalesced into our sun and planets. The forces that shaped our solar system continue to operate today, silently ensuring the stability and beauty of our cosmic home. Rest deeply now, cradled in the knowledge of our solar system's ancient, magnificent birth. A story where the initial whisper of gravity grew into the grand, harmonious symphony that governs our nights and days. Drift into slumber, knowing you are a part of this enduring cosmic legacy. Welcome back, serene spirit, as we gently continue our journey through the cosmic wonders that cradle our existence. We've traced the incredible story of our solar system, from the initial whisper of gravity forming our sun and planets, to the enduring dance of inertia, the subtle beauty of our elliptical orbit and its varying speed, and the crucial, stabilizing presence of our moon. Now, as we draw towards the conclusion of our exploration, let us cast our gaze into the very distant future, to contemplate the subtle, incremental changes that inevitably shape all cosmic phenomena, even the seemingly eternal dance of our planets. As you settle deeper into your peaceful rest, allow your mind to ponder the concept of time on a truly vast scale. While the Earth's orbit around the Sun feels incredibly stable and predictable to us, a rhythm that has governed human existence for millennia, nothing in the universe remains absolutely static forever. Over immense stretches of cosmic time, measured not in centuries or millennia, but in millions and billions of years, even the most robust celestial dances undergo subtle, almost imperceptible shifts. These are not sudden, dramatic upheavals, but rather gentle, ongoing adjustments, a testament to the dynamic and ever-evolving nature of the cosmos. One of the primary drivers of these subtle changes are the gravitational interactions with other planets. While the Sun's gravity is overwhelmingly dominant, the other planets in our solar system, particularly the massive gas giants like Jupiter and Saturn, exert their own small, gentle gravitational tugs on Earth. Think of it like this: if you were swinging a ball on a string, and every now and then, tiny, invisible hands gave the string a very slight, almost unnoticeable nudge. Over many, many swings, these tiny nudges could cumulatively, subtly alter the path of the ball. In the same way, the gravitational pulls from Jupiter and Saturn, though incredibly weak compared to the Sun's, can gradually perturb Earth's orbit. They might cause our orbit to become slightly more elliptical or slightly less, over cycles that span hundreds of thousands or even millions of years. These long-term orbital changes are part of what are known as Milankovitch cycles, named after the Serbian geophysicist Milutin Milankovic. These cycles describe how variations in Earth's orbital eccentricity, the degree to which its orbit deviates from a perfect circle, axial tilt, the tilt of our planet relative to its orbit, and axial precession, the wobble of Earth's axis, combine to influence the amount and distribution of solar radiation reaching Earth. These cycles, unfolding over tens of thousands to hundreds of thousands of years, are thought to be major drivers of Earth's long-term climate changes, including the advance and retreat of ice ages. So, While the immediate shape of our orbit feels constant over geological timescales, it subtly breathes, expanding and contracting, becoming more or less elliptical in response to the gentle, cumulative tugs from our planetary neighbors. Another, far more dramatic, influence on Earth's orbit in the incredibly distant future will be the evolution of our Sun itself. Our Sun, like all stars, has a finite lifespan, and it is constantly undergoing changes. Currently, our Sun is in its main sequence phase, steadily fusing hydrogen into helium in its core, providing the stable energy that sustains life on Earth. However, in about 5 to 6 billion years, the Sun will begin to run out of hydrogen fuel in its core. When this happens, it will undergo a profound transformation. The Sun will expand dramatically, becoming a red giant star. Imagine our familiar Sun swelling to an enormous size, perhaps so vast that its outer layers extend beyond the current orbit of Mercury, possibly even engulfing Venus and, in some predictions, even our Earth. As the Sun expands, its outer layers will cool and redden, but its overall luminosity will increase enormously. The gravitational pull of the Sun will also change as it sheds mass through stellar winds during this red giant phase. If Earth is not engulfed, its orbit would likely expand outwards as the Sun loses mass, but the intense heat from the vastly expanded Sun would render our planet utterly uninhabitable long before that. Following its red giant phase, the Sun will shed its outer layers, forming a beautiful planetary nebula, and its core will shrink to become a white dwarf. This will be a very dense, compact remnant of the Sun, about the size of Earth, but still incredibly massive. At this point, the Sun's gravitational pull would be significantly weaker than it is today because it would have lost a substantial amount of its mass. If Earth were still in orbit, a very big if, given the red giant phase, its orbit would expand dramatically, becoming much wider and slower, reflecting the diminished gravitational grip of the white dwarf Sun. These are incredibly distant futures, beyond the comprehension of our everyday lives, but they highlight the dynamic, evolving nature of all things in the cosmos. Nothing is truly static. Even the most stable orbits, the most enduring stars, are part of a continuous process of change, growth, and eventual transformation. This perspective, rather than being unsettling, can bring a profound sense of peace. It reminds us that change is inherent to the universe, a natural part of its grand unfolding story. As you allow these thoughts to gently settle into your mind, recognize that the stability of our Earth's orbit, which has allowed life to thrive for billions of years, is a remarkable privilege. While its long-term future holds grand transformations for now and for countless millennia to come, our planet will continue its stable, predictable dance around the Sun. This dance is maintained by the same fundamental laws we've explored: the delicate interplay of gravity and inertia, constantly adjusting, constantly balancing. Let the knowledge of these subtle, long-term changes and the ultimate evolution of our Sun fill you not with anxiety, but with a quiet sense of the universe's vastness and its endless cycles. Everything is in motion, everything is transforming. Yet there is a profound order that governs it all. Our Earth is part of this magnificent cosmic ballet, a testament to the universe's dynamic and beautiful design. Rest deeply now, knowing that our world is on a steady course, held within a stable system for countless ages yet to come, and that even the distant future holds its own form of cosmic beauty. Welcome back, beloved dreamer, for one final gentle whisper from the sleepy scientist. We have journeyed together through the cosmic realms, softly unraveling the profound mystery of why our Earth so gracefully orbits the Sun. We began with the unseen embrace of gravity, understanding its immense power born from the Sun's vast mass and our Earth's perfect distance. We then acknowledged the tireless spirit of inertia, that persistent forward momentum that keeps our planet from succumbing to gravity's pull. We marveled at the subtle beauty of our Earth's elliptical path, an elegant oval that brings us gently closer and then further from our star. and discovered the fascinating secret of its varying speed, quickening and slowing in a harmonious cosmic rhythm. We broadened our gaze to behold our entire solar system, a diverse family of dancers, each held in their unique gravitational embrace, and learned the crucial stabilizing role of our faithful companion, the Moon. Finally, we peered into the incredibly distant future, contemplating the subtle, long-term changes that shape our cosmic home over eons, a testament to the universe's dynamic and ever-evolving nature. As you lie here, fully relaxed, perhaps feeling the gentle pull of sleep drawing you deeper, let all these insights coalesce into a single, profound understanding. The Earth's orbit around the Sun is not merely a scientific fact, it is a magnificent, ongoing cosmic performance, a ballet of fundamental forces choreographed with exquisite precision. It is a dance born of balance, the gentle, yet irresistible pull of the Sun's gravity constantly drawing us inward, perfectly countered by our planet's tireless forward motion, its unwavering inertia, which perpetually seeks to carry us in a straight line. This eternal tug-of-war results not in conflict, but in a state of perfect, harmonious equilibrium, an endless, graceful fall around the Sun rather than into it. Think of the reassuring stability this understanding brings. Our world is not precariously balanced on the edge of chaos, nor is it rigidly fixed in an unyielding embrace. Instead, it is dynamically held, constantly adjusting its speed, subtly shifting its path over vast cosmic timescales, yet always remaining precisely where it needs to be for life to flourish. This intricate cosmic machinery, born from a swirling cloud of dust and gas billions of years ago, continues to operate with silent, unwavering efficiency, providing the rhythmic days and nights, the predictable seasons, and the stable environment that allows complex life, including our own, to exist. This journey through cosmic mechanics isn't just about learning facts, it's about connecting with something infinitely larger than ourselves. When you next feel the warmth of the sun on your face or gaze up at the moonlit sky, you now carry a deeper appreciation for the unseen forces at play. You know that you are a part of this grand celestial tapestry, intrinsically linked to the very movements of the planets and stars. The same gravity that holds you to your bed also binds the Earth to the sun and the moon to the Earth. It's a universal connection, a reminder that we are all interwoven into the vast, beautiful fabric of the cosmos. There is a deep serenity in this knowledge. To understand the elegant laws that govern the universe is to find a sense of calm in its boundless expanse. It's to realize that even in the face of the unknown, there is profound order. The universe doesn't operate on whims or chance. It follows timeless, predictable principles, and within that predictability, there is a gentle, comforting rhythm, a cosmic heartbeat that has pulsed for eons and will continue to do so for eons to come. So, as your mind quiets and your body grows heavy with peaceful sleep, take a moment to reflect on this cosmic embrace. Imagine yourself drifting in the gentle currents of space, feeling the unseen pull that keeps our world afloat, secure in its continuous journey. Our Earth is a magnificent vessel, navigating the cosmic ocean with unwavering purpose, guided by the elegant dance of gravity and inertia. This knowledge isn't meant to keep you awake with wonder, but to lull you into a deeper, more profound state of rest, knowing that your world, and indeed the entire solar system, is in perfect, harmonious order. Let the quiet certainty of these cosmic truths become a soothing lullaby. Feel the profound connection between your own stillness and the silent, majestic motion of the universe. The very air you breathe, the ground beneath you, the light that warms you, all are part of this incredible, ongoing cosmic dance. There is no need to grasp or to strive, simply let go and allow the universe's inherent order to carry you into a peaceful, dream-filled slumber. Sweet dreams, quiet observer. May your rest be as vast and serene as the cosmos itself.